Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Techstrong Learning Experience brought to you by ConnectAll. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting presentation ahead. Before we kick things off, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or perhaps you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you'd like to chat with our speakers today, you can do so using some options on the right side of your screen. The first option I'll point you to is the chat tab. I'd like you to click that chat tab and start typing to us right now where you are joining us from. Now, if you have any questions, I'd like you to direct those to the Q&A tab directly to the right of that chat tab. And if you click the handouts panel, there is a copy of the slides today that you can download, so feel free to grab those to follow along. Of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our program today. So our topic is using value stream automation patterns and analytics to accelerate DevOps. I'm joined by Lance Knight, President and COO of ConnectAll, and Soumya Menon, Head of Content at ConnectAll. So Soumya and Lance, thank you both so much for joining me today. Lance, do you want to go ahead and introduce yourself and take it away?
Sure. I'm Lance Knight. I'm the president and CEO here at ConnectAll, and I've been in this value stream management space for some time now. And I've kind of put this presentation together today to just get some theories about how you can use patterns and analytics to figure out how to automate in DevOps. And Soumya and I are going to go through and have a conversation around these slides. Feel free to ask some questions as we go along. Here at ConnectAll, we've really been focused on figuring out how to help organizations to be more effective in software development delivery. We spent a lot of time trying to understand how we can help organizations find places to automate, use solutions like ConnectAll's to be more effective. So at ConnectAll here, you can see this is our product here, and we allow organizations to actually automate the flow of work between their different tools, whether that's in their DevOps pipeline or so on. There we go. And later on through the presentation, these automations that I'm showing, we use to gather metrics and do different things with. And one of the interesting things, we're going to talk about how you can use some of these metrics to find patterns, to find noise in your value stream. Metrics like flow metrics and so on. Getting back to the presentation, what we've kind of uncovered or started to talk about, Soumya and I, is that, software delivery is a little noisy, right? So remember we were talking about how there's just a lot of noise that happens that, denigrates or slows things down. And that noise comes from all kinds of places. And the more work that goes into your system, the more feedback noise is created, the more emails, the more things to check are created, and that slows down and retards your flow and makes things slower in software development and delivery. What we like to say is that it's chaos. It's chaos. The software development delivery is very chaotic, and it's very unpredictable. And it's something that has to get to predictability. And that's why at ConnectAll, we're kind of talking about these things about pattern thinking and understanding how to turn this chaos into order by using some of these principles that I learned in manufacturing, principle that Soumya has been along this journey with me and understanding how to use them in software for a long time. What's it been, 5-6 years now?
About 6 years, yeah.
Yeah. And I remember when we first did a whole webinar, or actually I was at front of somebody doing the first speaking slot in 2017 about systems thinking and lean principles for software delivery and how you can improve flow. And that's essentially what we're talking about here is how do I use pattern thinking to do that? And what is pattern thinking? Now, we had a great conversation the other day about this, Soumya, where we talked all about how you can use it to uncover all kinds of things. And organizations show patterns as you start to look at this. Patterns like over governance patterns, or even what was the one you said? Over processing?
Overprocessing, overproduction, excess inventory, delays, defects. So yeah, there's a whole lot of patterns that you can uncover. And
Yeah, so
the closer you look,
yeah,
the
and
closer
so
you look, you see more and more. So
yeah, so like and then when you see some of these like over governance, where they're doing too much governance in their system or too much over meetings and processes, this starts to really amplify what we're calling feedback noise. So pattern thinking and systems thinking can help you with this. And these are some of the tools that we're going to talk about that you can go out and study and educate and use in order to find out where you can find areas of automation in DevOps and software development delivery. We'll talk about systems thinking, something I've been talking about now since before 2017. Lean principles, value stream mapping is a great tool, but a systems diagram is really interesting as well, because that helps you uncover some of these noisy feedback loops that you can automate your way through. Now, what are the other? Oh, we're going to talk about SIPOCs a little bit too, right?
yeah.
Yeah. So, what is systems thinking? Sumi, I'll let you give a crack at it. What's systems thinking?
Did you ask me what systems thinking is?
Yeah, it's on the slide here.
Yeah. So anything that you, it's a set of activities that anything that you put into a system, and there's a certain order in which it flows through, and there's output. Anything that is, all elements within a system are connected, right? And it forms a certain form of pattern. You actually see those emerging in the system. So yeah, they're all interconnected.
Right. So it's a set of it's really is a group of elements that are interconnected to create something, right? And those patterns come. And there's different terminology we use in systems thinking: causality loops, synchronization, reinforcement loops, balancing loops. All these things kind of come into play when you're looking at how to look at mapping a system. Feedback loops are a big part of that, and how everything kind of works together is part of this whole systems thinking. And if you start to take this and apply it to software development and delivery, these patterns emerge as well, and then mapping that as well. So quick education on systems thinking. What is it? I usually use this very simple analogy, which is a clothes dryer. And I think most everybody knows what a clothes dryer is. But a lot of the clothes dryers, just like software development delivery, it's a black box to people, right? You put clothes in. These are the things that go in: wet clothes, cold air, and electricity. Those are your inputs. It goes through cycle time and emerges dry clothes. That process from dry to wet is called phase transition. But it's black box. But there's more to it than just that. There are elements in that contained system. There are a group of elements in there. And the elements are defined as pieces of the system. For example, basic elements in a dryer: the heater, the drum. There's an electric motor to turn the drum. There's a fan, there's exhaust. And these things kind of work together. So to dry the clothes, the heater heats up, the motor turns the drum, and the fan moves air through. But there's more to it. There's feedback loops. There's all kinds of different feedback loops that are used in order to make that happen. Feedback loops like synergies. So there's synergies between the different motors, synergies and dependencies, things like that. Potential bottlenecks and constraints that also work as well. So these are used in different ways in order to understand that. So for example, if the motor starts to overheat, there's a feedback loop to turn it off, a sensor, a filter, or something like that. Do you have experience with dryers, Sumya?
I do, but I have a broken one right now. So yeah,
Maybe you can
that's
figure out
why.
how to fix it, right?
Yep.
So anyway, so past that, then you start to look at lean principles. Now that you understand all of this system stuff, you start to look at lean principles. Lean principles like understanding these 5 areas, these 5 different areas of lean principles with identify waste. And what I like about understanding lean and lean principles, it gives us a way to communicate about things. How to communicate about what automations are. It gives us a way to communicate about things that are wasteful and so on. So first thing is create flow. You want to be able to create flow. So that's your WIP limit. That's those types of things. You can use Little's law in order to understand, but you can see that as more and more things go into the system for these two as it's flowing, your loops and things are starting to fall apart. So for example, they can't keep up. So there's noise in the system to be able to manage all that. So you need to take a look at that as those things are moving fastly. There's different areas of waste as well. And this, again, what I like about lean is gives us a way to communicate. This is called Muda. And when you're looking at your system maps and your systems diagrams, you can figure out how to eliminate over processing waste, do all this other stuff that you want to be able to do within the system. Remove wait state, inventory, all of these different things. And then you can use these maps and things that you're using to identify non-value added activity also. Give me an example of non-value added activities, Sumya.
So let's say you're sending a lot of emails to communicate with you're a developer, and then you need to send emails to update about your code, and or you need to update an Excel sheet. These are some non-value-added activities that exist in any software system, and definitely needs to be eliminated. And either eliminated, or you could, if they're necessary, then you can automate them. So
right. So once you identify it, right?
Yep.
So and then you got to decide, is it necessary, right? It might be necessary, and then you can say, then I need to automate that as well. Another tool we talked about is SciPocs a little bit, right? Right, so we talk about SciPocs a little bit.
Yeah. SciPoc is important. It's an important tool, not just to identify patterns, but it's an important step when you're using as well. So,
right. So then when you look at a system, you use a SciPoc, and you could say, this is the supplier, these are the things, right? Whether that's the water, the heat, those types of things. And here's are the inputs. And then I can start to look at for areas that I might want to improve there as well. All of these different tools allow us to figure out how to be more effective and identify patterns.
Yeah.
You can map the value stream too. Value stream mapping is part of lean principles, where you look at how is all that's flowing. And one of the things I find interesting is if you take a causal diagram or a systems map and you put it over top of a value stream, interesting things start to uncover in that process. So, for example, this value stream has flow, it has different things in there. And I call these the 3 phases of what I call the software development value streams, right? You have your portfolio flow where requests flow in, and you can look at times and how long things take through that. And of course, you have your development flow. That could be agile, backlogs, planning, and done. And then you have material flow, which is your code commits, your test scans, your builds, those things that end up in production and customers. And there's feedback loops all throughout here. And one of my points of view is that value stream map isn't enough to improve your software development delivery. You have to look at these causal loops, these feedback loops, and find out where you're spending a lot of time there. So how do we use these things together? So, we've got systems thinking, lean principles. How do we use these to find patterns and uncover places where I can automate to be more efficient and more effective? Well, I call it the 4 ways to identifying patterns. The first one is identify all the elements in your system. Then map the value stream, create a system map, and then analyze your metrics. Now, earlier I showed you some metrics. We'll talk a little bit about that as we're going through. So, assuming there's all kinds of different elements in the software delivery value stream, and I look at these things, those artifacts of that. And I think every organization is different, and they have other elements as well, right?
Absolutely. And there are sub-elements as well. So there are elements within elements.
Right.
So, yeah.
And each one of these elements is what we use to actually, it's funny. So there's different types of elements in here as well. So for example, you have code commits and builds and releases. Those are elements in the system. Those are the material flow. All the rest of these elements only manage the work that's getting done in the process. And there's a lot of feedback noise against all of those. It's kind of interesting. Then you map your value stream and try to take a look at how these things are flowing for your system, right? It starts with, planning, which is portfolio, code, test, deploy, your material flow, all these things you can map and use a governance model. And then what you want to do is actually overlay a systems map like this that actually talks about how all those elements in your system work together, how a request amplifies the number of epochs, and then there's noise that happens around there. So all of these things create feedback loops, create all the things. So matter of fact, if you put a request in one system, somebody's got to then take that request, key it into another system, and have it be an epoch. And then the more you do, the more of those loops take off. And then what happens is you start to collaborate around that epoch. Now you're sending emails, you're sending chats, you're having meetings, you're doing all the stuff around that, which never gets caught up or put in place when you think about a value stream. And that's the same when you're working with the code down below. The code, which is code commits, creates all that work as well. It has test scans that have to have feedback loops. Then we're creating emails around that. All of that I call feedback, which is really important, but it gets to be noisier the larger your organization is. And it can have an effect on you in that way. So you want to overlay these artifacts and the relationships over a value stream map and map how they work, but map the feedback loops too. Just not the relationship between the artifacts. What conversations are happening? What meetings are happening? How can I remove that waste? How can I find the non-value added activities that are going on as you're developing software, right? So there's all this activity that's happening that's creating all of this noise and reducing your flow. For example, in here, you may have a scanning tool that has to bring data all the way back into your backlog as a defect. Well, somebody's taking that, copying that, or emailing it. All of that is noise in the system that you can then automate. And when you're looking at your analytics and your metrics at the same time, you can look at all different types of metrics to say there's too much noise in the system. For example, defect escape ratio. If you get a lot of defects, that means something's going on in the system where you're not collaborating and you don't have the right feedback loops. Your throughput, what you're putting through your system too. All these are indicators of where areas you can automate and that there's too much noise in your system. So if you look at defect escape ratios, you can look at the team and understand what they're doing. Is there a place where I can automate? Maybe somebody's keying things in a lot. In different flows, or the approval process isn't working right before that and those defects are going on, and you can go look at that. You look at your flow load as well, where you can look at what am I working on. Well, if I'm working on more bugs and defects, what's going on downstream? Now, is there a place where I can automate that and make that more effective? Automate maybe the way we're spinning up tools, or maybe just things like that. So at ConnectAll, we've done a lot of work on this, and we have I don't know how many patterns we've uncovered where there's examples and benefits where automating the flow of work, both from code, from idea to code and production, both the DevOps pipeline and the value you're delivering, and connecting those all the way through, help organizations quite a bit. For example, one of the ones I think we have laid out here is what we call governance to deployment, and that how you can automate that rather than making it something where people are looking at these things and your ticket doesn't even get created in a system until that happens. That's this particular pattern where I look at somebody puts a change request in ServiceNow, but if the right test results aren't there, he can't trigger a build to happen in Octopus Deploy. We're using our logic gate adapter for that. You're familiar with this pattern, Sumya?
Absolutely, yes, I am.
So, and there's other patterns too in the DevOps pipeline that you are working on with product management as well.
Yeah, we have uncovered several patterns within DevOps and Agile, of course, and these patterns are important to get rid of inefficiencies. So it's not just governance. There are anything that blocks the flow in your value stream. These patterns will be pretty effective. So
Yeah.
this is one such way, like a pattern that uses logic adapter that helps you, enforce governance throughout your DevOps pipeline. So
Right. So by doing this, by removing that waste and working with these patterns and doing so, the whole goal here is to reduce what we're calling feedback noise. Feedback noise happens when things are over amplified. When you start to get to be bigger teams, the trading of emails between systems, the noise of all of the work that's get broken down creates a process where your flow is impeded. It reduces your velocity. You'll find that if you have a lot of feedback noise, you'll be in more meetings than you ever thought before, and that there's a lot of slacks and chats as you're trying to communicate on this stuff, and that noise can be reduced by automating different pieces of your value stream. And really, that's all I had to talk about today. And I'm game for questions. Assuming there are a couple questions in there, if you could read them off, we'll handle them.
Sure. So we have one here. They're asking us, how do you handle silos? Because traditional software development organizations are often structured in silos with separate teams responsible for development, testing, and operations. So this can lead to communication breakdowns and delays in the process. So I think we've kind of covered that, but Lance, if you want to elaborate.
Yeah, so you look for patterns of communication between those silos so that you can do it. Matter, a lot of the patterns we have laid out are about feedback loops between the silos. So those feedback loops are like development to test silo, right? So I got my QA team and they're working in their tool and they have their artifacts and their elements. When you're looking at how they amplify each other, you can figure out a way to automate that. So all of this is actually about bringing those silos closer together and how they interoperate and work together, both by automating the way their tools communicate, automating how they. Another pattern is the incident to request pattern, where somebody puts an issue in or an enhancement request in ServiceNow. That's a silo, your ITSM silo, but we can automatically flow that to the developer's backlog and modify that particular backlog loop. So that way you're not keying it in, it automatically happens. So all this is about breaking those silos down.
Absolutely. We have another one. Are we saying that all manual activity can be attributed to noise? And as such, automating helps to remove noise and streamline things. Further is feedback loops. I'm sorry. Yeah. Further, is feedback considered noise as well? Like the manual handoff of feedback, is that considered noise as well?
So not all feedback is noise. It depends on how much feedback is going on in the system. And some of that feedback can be automated or removed based upon whether it's value added or not value added. It could be over processing waste. But a lot of feedback is necessary, balancing feedbacks to reduce risk. So no, not all feedback is noise. Not all manual processes are noise either. Some are necessary. But the bigger your system is, the bigger your noise gets if you're not automating and looking for ways to improve flow.
I have another one around feedback, which is how do you typically establish feedback loops, and how much is automation a part of that, and how does it help identify bottlenecks?
Yeah, so that's the interesting part as we're talking about feedbacks a lot is I have learned that in software development delivery, when people try to improve flow, they're not paying attention to feedback loops, all the ancillary manual things that are going on. For example, if you're collaborating on a user story between dev and test on acceptance criteria, that's happening in emails and chat and all these other places. That can create quite a bit of overhead and feedback noise. But if you automate the systems and the way they're communicating, where you can collaborate on creating that, now I'm going to reduce that noise. You're not going to get rid of it. Some of that is necessary, but you want to do as much as you can to reduce it so it's more streamlined and your flow is not effective. So there's manual feedback is considered. You want to map manual feedback as well, because you might find out that you have over governance going on inside there. So if you're mapping all this and looking at how people are interacting from a full systems perspective and using causality and all those other things, you could start to see where organizations tend to do maybe over governance. And then you start to say why. And then you might realize that you don't need to be that restrictive, and then you'll improve flow and your velocity again as well. So what I found is most organizations aren't really looking at how the organic system of software development and delivery works as well. They're looking at the more rigid process system where there's humans involved and things are happening, and value stream management is human. So anyway, hopefully that answered your question, but go ahead. Assuming there's quite a bit in here.
Yep. There's one way someone's requesting how the AND gate works within that governance pattern. How does that logic gate work?
So these are the logic gates here. And so this is a new innovation to Connect All this year. You actually can map elements from each one of those systems. So I have a change request in ServiceNow. I mapped that into the logic gate. I have a test results. Those are mapped in. And then inside there, you say, if change request is this and test results are here and test results from SonarCube are here, trigger the build. So if I put a task in ServiceNow, it could say, all right, that task says trigger a build. Connect All will see it and trigger a build. With the logic gate adapters, it'll only trigger a build if these test results are positive or negative. If those test results are in a certain parameter, if they've happened and they've passed. So that allows you to put logic into the way you have things flow within Connect All. It's a great new enhancement of ours that we just came out with about a year ago, I think.
Yeah. So we went through this lens, we defined what feedback noise is or what noise is, but we could reiterate asking, how do you define or identify noise?
So defining feedback noise is an interesting one. So we look at it as like any type of amplification of communication, right? So in systems, when I put more and more into a system, that creates more and more elements that move through the system. That creates more and more feedback. That amplification of the feedback is what I call feedback noise. The feedback's not noise. It's just when you have so much feedback going into the system, that creates noise and makes it difficult for you to manage flow, manage the business. So you have to understand all of those feedback loops, what they're about, figure out if I can automate them, remove waste, figure out if they're non-value added or value added. If they are non-value added but necessary, how do I automate it? So it's not the feedback that is not one individual feedback that is noise, or feedbacks are not noise. It's the amplification of feedbacks based upon your system and all the work it takes to do that feedback. For example, if I've got to send 5 different emails to solve one small thing, that's 5 pieces of feedback. How do I reduce that? How do I automate that? How do I look at how the human factor comes into play here as well and try to create that? Another thing would, let's say you're having all these meetings around all these defects. Maybe there's another way to do that. Maybe that meeting is part of what I would call feedback noise. So it's really looking at it from a systems perspective, figuring out if you have too much noise, automating if you can, and reducing the non-value added things that are going on. I answered that one pretty good, didn't I, Sumya?
You did. I look at it in the form of acoustic feedback. I mean, I know it doesn't really align with software delivery, but then when you have an external noise, you have that feedback, which is really, really loud, right? And that creates noise, and it's continuous. So the more, like you said, Lance, the more you put into the system, the more noise it is creating, right? So
right.
That's how I look at noise.
Yeah.
We have one more last question. It's to do with silos. So in addition to silos, which is under a centralized architecture, what are your thoughts on structure for decentralized organizational units or divisions?
What are my thoughts on decentralized organizations and divisions?
Yeah.
So I'm trying to wrap my head around, what do you mean by decentralized organizations and divisions? So if you're talking about people not centralized in one place, then all of these still apply from a systems perspective for developing software. Doesn't matter where you are. If you're talking about communicating across non-centralized software, then you can map that out as a system. So it really doesn't matter whether it's centralized architecture or decentralized. All of these still apply when you're thinking about how you put your system together.
Okay.
Cool.
That's all the questions we have for today.
All right. Back to the moderator.
Well, awesome. Lance and Sumya, thank you both so much for joining us today. Always appreciate getting to talk to you guys before we go live. So it was good to have you on with us on Techstrong Learning. So I would like to remind our audience that our session today was recorded. So you will be receiving an email with a link to access this recording on demand. Of course, you can find it living on the DevOps website at devops.com/webinars, and then just be sure to look in the on-demand section. The 4 winners of our $25 Amazon gift card drawing are Megala R, Connie H, Timothy M, and Ann D. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. It should make its way to you in about the next 48 hours, but if you don't happen to see that email, check your spam folder just in case. I'd like to thank Connect All for sponsoring our program today. And to everyone who's been with us for the past half hour, thank you so much for being here with us. We really value your time and we want to hear your thoughts. So as soon as we close out, there will be a survey that pops up on your screen. Let us know what you thought about our program today, or if you have any suggestions for a future program. Either way, we do hope to see everyone at an upcoming Techstrong learning experience. Have a great rest of your day, and Sumya, Lance, thank you both so much.
Thank you.
Thank you. Thank you.
Bye-bye.